So hey guys, we're going to show you how to import and use NLTK, assuming you have pip installed in your system. First you have to just import NLTK like any other library, and then by using NLTK.download and seeing this window, you just select book, download, and then you have all the books in your system. So you just write from NLTK.books import everything, and this will import all the text in your Python file. You will see 9 texts being loaded. And today we're going to use the first one in our examples. It's the famous Moby Dick. The first call function we want to show you is called concordance, and it finds how many times a word appears in a text. But you can see that not only it finds how many times it appears, but also in which sentences it appears. So it's perfect for text analysis. The next thing we want to show you is a function called similar, which really easily just finds other words that are used in a similar context as the one you passed. The other useful thing we're going to show you is dispersion plot, which by passing it some words, it looks and analyzes how these words appear in the text. And you will see a lexical dispersion plot, where you can see not only how many times a word appears, but also at which section it appears. You can see the word whale appears most of them, and it's really densely at the middle of the text. The word sea appears evenly everywhere in the text. The word boat at first doesn't appear, but it appears later on, and the word wave don't really appear. Moreover, we'll show you a really important thing NLTK uses. It's called frequency distribution, and by just using this function, you just don't need to use and count anything, but just passing it into a variable and then plotting it, you can see all the words in your text and how frequently they appear inside your corpus, just by using one little function and not having to write any code. Furthermore, we're going to show you something really important. NLTK can be used in cleaning text, something you will surely have been in need of when trying to create bag of words in this class, and you would have used really complicated regular expressions, but now we'll show you how to do it better. We define the sample word, and then we apply functions on it. You can check if this word is a digit, if this word is a word and contains only letters. Just by these two functions, you can clean everything. But you have more. You can check if a word starts with a specific letter, or if a word is uppercase or lowercase. Then we're going to use NLTK in some other kind of text beside books. So we're going to import state union corpus from NLTK. This contains all American president speeches, and now by printing the file IDs, you can see that it contains text from 1945 and Truman up to 2006 and George Bush. We have prepared a code snippet for you, which looks for 3 specific words inside all the texts, and we're going to plot the results and analyze it. You can see we have been looking for the words men, women, and people, and you can see that people clearly are used more than any other word throughout time. But it's really interesting to see how women during all the time have always been lower than men, but only came on top of them around 1980. And it would be really interesting to see what happened in these points. So just by using this huge corpus and some clever tricks by NLTK, you can analyze any kind of text.
So now we will give a general overview of what Hadoop is, and we will introduce Spark in detail. In case you have tens of terabytes of data up to petabytes and you need to do processing in 10 or more computing nodes, we should consider big data tools and approaches. Hadoop was the first generation of such tools. Later on, a project called Spark was started. They looked at large Hadoop distributions and found where the problems were, and they tried to solve them. The big difference between Spark and Hadoop is that Spark tries to optimize in-memory computations so it keeps the data in the memory. Here we have an overview of what is Hadoop. Hadoop is mostly a Java-based implementation of some ideas that came from Google. At the core of it, it's something called HDFS, which is the Hadoop file system. Essentially, it's a file system which works on clusters of computers. A file is split into large chunks, let's say 100 megabytes. Generally, big chunks of data are processed at a time. It replicates these big chunks in, let's say, 2 or 3 computers, so if one of them dies, your data remains. More importantly, you can ask in which computer your chunks are located, and you can schedule your computations on the computer where the data is. Therefore, you don't need to move data around the cluster. Below HDFS, there are some schedulers of CPU, RAM, and hard disk space in a cluster. Below that, there is a coordination service. It's called Zookeeper. Above the file system, there are computation layers. First one was MapReduce. Then Spark came. Test is a bit similar to Spark. The new project from Europe is called Flink, but it's not very popular yet. Then there are a bunch of different key value stores. HBase is one in Hadoop and Cassandra. Finally, there are a bunch of query engines which basically allow you to run SQL in top of data store. Hive is the first of them. Then we have Spark SQL, which uses Spark to implement SQL. When it was released, it was 5 times faster than Hive. Impala is another tool, and there is also Stinger. We will be mostly speaking about Spark. MapReduce is not very productive compared to Spark, for instance. The problem with MapReduce is that it's very verbose. It has high overhead of starting jobs as well. Then, many real-world computations really consist of sequences of MapReduce jobs, often in a loop. MapReduce, after each iteration, it saves everything back to disk, which means that even if your data could have fit into RAM of your machines, it will be written in the disk and then read again. This makes you extremely slower compared to the case in which you could keep it in the RAM. This is one place where Spark really shines. So, what Spark does is improve in terms of productivity and performance. You can write a program in Spark with 10 times less lines of code. It can be written in either Scala or Python. Python and Scala have this command line called readable print loop, where you can type in something and you get immediate response. This allows you to be very productive and test your things fast. The second difference is performance. It could be in certain cases up to 10 times faster than MapReduce. What happens is that it keeps the data in memory when possible. That's how it looks in Spark. Here we have the workaround program written in 2 languages, in Scala and Python. The first line creates something called RDD, which is the resilient distributed dataset. Essentially, all the transformations happen in terms of RDD. So basically, a file is a RDD. Then you apply to this file a flat map and a map, which produces for each line a bunch of key value pairs, like word, 1. Then we reduce these values by the words, and the result is a word count. Spark consists of a Spark core, which is the main execution engine. It works on top of the schedulers, the jar and the message, or it has one of its own. On top of a Spark core, there are relatively small libraries for implementing Spark SQL, Spark streaming for processing data in real time. There is a machine learning library which implements some machine learning algorithms using Spark. There is also a library for graph processing. So that's the general structure of Spark. The RTDs are the datasets. The dataset is basically a sequence of values that are partitioned into pieces, and each partition can live in a separate computer. Typically, you do partitioning on a key. There are a bunch of transformations on these RTDs, such as map, filter, flat map, join, and so on. Then there are a bunch of actions such as reduce, collect, save, which will force the computation and then produce the output. Regarding Spark SQL, it can implement SQL queries on any data source. They actually have an optimizer of queries called Catalyst, which is a logical optimizer. Basically, you have a query, logical optimizer runs, and tries to reorder the joins in order to optimize the query. In general, intermediate results are compressed and stored in memory. When it was introduced, it was 5 times faster than Hive, due to these optimizations in RAM, computing, and compression. Here is just an example of the API. So, you create first your RTD by reading a JSON file, you register it as a temp table, then you can just run the query which does something with this table. Obviously, you can have many tables, you can join them, and so on. There is also this data frame API. Essentially, you do the same thing, but you just express it using an object-oriented API. Data frame is a bunch of columns with names. Here we have a data frame called people, we select column age, we filter by the age, and finally we select the name. It's just a different view of the SQL query.
So on this part we're going to see how to install PySpark on a Unix machine. Here we have an Ubuntu virtual machine with no software pre-installed to go through the entire procedure step by step. First of all, we'll have to install the Java development kit. So it's in the default Ubuntu repositories, and with a simple command we can install it. It's actually needed for PySpark to run. Now we will of course have to download Spark. We can go to the website and choose the version that we want and the pre-built package so we don't have to compile it, and click on the download link. Now if we don't have a graphical interface, we can do this through the command line with a wget command, and providing the link we can download Spark. Now we can see that in our directory we have the compressed file, and we'll have to extract it with a tar command. Here we can see the file that contains all the binaries. We would like to create a directory in the root folder for the application to run, and we're gonna name it SRV, and then inside we're gonna create a Spark 1.5.2 directory because we may have different versions of Spark actually, and we're gonna move the binary file into this directory. Now we'll need to link the file with the binaries to a simple Spark file where we can link any version of Spark that we want and make it run from there. SRV Spark will be our new directory. Now if we try to run PySpark, we're going to see that actually the command is not found, and that's because it has not been exported in our universal environment. And we're going to have to add a couple of lines into the bash shell configuration file. We can do this through the set command that we learned in class, and we're going to append the first line, as we can see here, with export and the name of the variable that we want to assign to the directory, and the name of the file at the end. That's the busrc file. We're going to need another line in the busrc file, and in that we're going to set the path at the variable that we declared previously to be that of our current path. And again, we append this line to the busrc file. Now if we restart our terminal and run PySpark, we can see that the environment starts loading all the necessary modules, and in the end we have Spark up and running in our system, like a normal Python environment. In the next part, we're going to try to link PySpark to NLTK and use them together. Here we can see a file that was downloaded in the NLTK environment, and we're going to try to implement a small code into that file using NLTK through PySpark. First we'll load the PySpark environment, and after we import the necessary packages with NLTK, we will create a dataset with Spark context, and we will have to give the universal path to the file that we will want to load. Now through a small script that we have prepared, we can see that we can load the sentences through the dataset using some NLTK commands to isolate the sentences, then the words in the file, then to tag them and count the nouns, and then keep the 10 first nouns that appear in the file. And after the code runs, we can see that we can print actually the first 10 nouns that occur in the file. So we have PySpark and NLTK running.